I've got 185 slides to get through, so we need to get started. I'm just joking. It's only 130 slides. My name is Alex. If you're not interested in AI or don't believe in it, the door is over there. You're probably in the wrong room. I'm going to try to give you a little speed run through 10 tips with a bonus tip to get better results from AI-assisted coding. So yeah, I'm Alex. I used to be a developer many years ago, and then I had a 10-year hiatus in running some companies. And I got back into coding about 2 years ago, and it was quite interesting because it was sort of early days when it comes to AI coding, and but I had to sort of relearn how to code. And it was interesting because obviously the fundamentals were the same for me, but a lot of the frameworks and technologies had changed quite significantly since, let's say, 15 years ago. So it was interesting to sort of relearn with the help of AI. And today, I've sort of been fortunate enough to spend the last 2 years sort of walking alongside the evolution of AI-assisted coding from it really not being useful at all 2 years ago, barely being able to do some intelligent autocomplete, to where we are today. And I think I have a lot of friends that are developers as well, and there's a lot of skepticism. So let's just sort of take the cat out of the bag. A lot of people hate AI in the context of coding, and I can to some extent agree if you started a year and a half or longer ago, because it was really not that useful. And yes, I know there's a lot of AI slop, there's a lot of excess code, unnecessary. And I think if you sort of just try it a little bit, you're not going to get good results. So I think we need to also invest some time in order to get good results. But I've gone through this sort of painful learning experience, and I thought I'd just share with you what I've learned that works and don't work, so that maybe you can save some time on your journey, and you don't have to go through all that pain. So that's the purpose of my talk today. I'm not going to force anyone. There's, perfectly fine to be skeptical, and you can have your opinions. I'll be happy to have discussions afterwards as well. But I'm not going to try to convince those that are sort of just saying, yeah, I don't believe in this and it's never going to work. So how many of you, raise your hands, how many of you are using some sort of AI assistant in your coding? Good. How many of you are using something like Claude Code or Cursor? Okay. And then how many of you are using Copilot? Okay. And then I guess the last question is, how many of you are using ChatGPT, asking questions, and then copy-pasting code back into whatever your favorite IDE is? Yeah? A lot. That's where actually a lot start, and I think that's also a great place to start. But you're missing out. If that's the only tool you have and the only sort of place you can work with AI, you're missing out on a lot of value. And I'll be honest, when I started as well, it was sort of, it was sort of barely useful, but I started quite a long time ago. And I've sort of seen that in very short amount of time, we've taken quite significant leaps in capabilities with these models. Even though they're fundamentally predicting the next tokens based on context, etc., it's a bit of a sort of too simple explanation these days. I don't really care too much about benchmarks. What the values or the numbers mean doesn't really matter. But what's interesting when you look at benchmarks, and you can look at any benchmark, is sort of the progress on the time chart, and essentially the comparison between where we were X months ago to where we are today. And just looking at something like this, just a year and a half ago compared to where we are today, I would say that's the Stone Age compared to where we are today in terms of capabilities of these coding assistants. And just, since I made this talk a few weeks ago, everything changed again, because then all of a sudden we got 2 new significant model upgrades. One being Gemini 3 and the other one just last week with Opus 4.5, which just takes it to a whole new level. So again, forget about all the numbers, but on the previous chart, I'm going to go back, you can see this was back in April, so let's say about 6 months ago. The best of breed then was O3 with terminal capabilities. And you can see that O3 is here on 35% on this very hard software benchmark that they're using now to test agentic coding with access to terminal. And you can see that we've got the latest models now have increased dramatically relative to where we were just 6 months ago. So it just opens up a lot more possibilities. I'm not saying it's perfect, but the models we use today are the worst models we're going to use for the rest of our lives. And I think we need to just have that mindset. The other thing I want to say is that the things that I'm going to go through today, I'm going to do a bit of a rapid fire thing, so it's going to be fast and it's going to be me saying a lot of stuff, but I'm going to share the slides so you can go through it afterwards if you want to. But most, if not all of the tips apply no matter what your favorite coding assistant is. But that being said, some of these are CLI based and they have an edge in some ways. Of all of them, Claude Code has sort of been the front runner, and everyone else has stolen with pride, which is perfectly fine. So you can do most of the stuff you can do with Claude Code, you can do with most of the other tools, but there are some things that up until now only Claude Code can do. One of them being sub-agents with a dedicated context window. So I'll get back to that. That's a very powerful feature. But apart from that, most of these tips will apply across the board. The other thing that I think is something that I realized is that you will eventually, if you go all in on this and you sort of embrace this way of thinking and working and coding, you might find yourself in a situation where you move from sort of giving instructions to one process and eventually ending up with being an orchestrator across multiple processes. It's a different way of working. And I think when you move over into that space, and I think that's going to be the future for a lot of us, we become sort of the bottleneck and not the AI. Because our sort of cognitive load and our ability to tend to these agents and to actually context switch is limited to our ability to context switch. But it's fascinating. So fair warning, if you do this, I have to admit, since I've done this, it can be quite addictive, and it can be quite expensive. So just be aware, if you go all in and you end up having 10 agents working for you, that adds up in terms of costs. You have max plans, which sort of reduces the cost a little bit. But once you sort of give into this, it opens up some quite interesting ways to work and to develop. My wife has not been very happy about it when I'm at the beach on my mobile phone checking during our summer break, checking that my agents are not idling and they're actually occupied working for me. But yeah, it can be addictive. But it can also be very fun. And I think, you know, a lot of this, we're obviously technical people, but actually a lot of this is not really technical. It's really about a mindset. And a lot of people ask me, how do you use AI? And I've been reflecting on the question itself and the way we phrase it. And of course, AI is a tool. But at the same time, I think it's a little bit cliche, but I think if we think of it as a tool and sort of treat it as a tool, we risk ending up in situations where we say, well, the results are crap, hence it's not the right tool for the job. And we sort of discard the tool. We throw away the tool. But instead, if we, I know it's cliche, treat it as maybe a junior developer or an intern, and very eager intern maybe is the right way to describe it. If we treat it like that instead, and have that mindset, we probably wouldn't fire that intern when they gave us mediocre results. We would probably give them feedback. We would probably tell them what's missing, what we want more of, what we want less of, and why we're sort of disappointed. And that's exactly the way we need to treat AI. Not just coding assistants, but any AI. But in particular, coding assistants. So that's tip number 0. It's an active choice. We can choose to just ask and accept responses, good or bad, or we can have this pair programming mindset when we work with AI coding assistants. And what I mean by that is we can choose to be lazy and just sort of do this and then accept the output, not even reading the output, which I think is unfortunately what a lot of young, fresh out of school developers are doing these days, is that they've grown accustomed to working and relying too much on AI coding assistants, meaning that they are maybe not learning the craftsmanship that is required to get excellent result rather than just mediocre results. But it's an active choice we have, right? We can actually tell the AI to walk us through what it did. We can tell the AI to explain. We can actually learn from the process. We can ask the AI to challenge us, and we can challenge the AI. But that's an active choice. We can do this in a collaborative way, or we can choose to be lazy. And I think we risk becoming less and less intelligent in our jobs if we end up in the first category. So the great thing, and I sort of get surprised by this, but I have to say it, a lot of the times people say, wow, I hadn't even thought about that. And I think that's the thing with AI. We just need to open our minds and think a little bit outside of the box. And a lot of the time, it's just about inviting AI to the table, asking the questions to the AI. So for instance, ask the AI, how could you help me become a better programmer? How could we better collaborate? You'll get answers, right? How could we explore our code base? And give me 10 things that I could ask you to learn more about our code base. You can just say that to the AI, and you'll get responses. Not all of them are good, and you might then say, well, some of this is shit, so everything is crap. But you can also view it this way, that, well, some of it is, but 3 points here are actually really useful, so I'll dive into those 3 points, and I'll explore those 3 points. It's an active choice that we have. And I think that's the key point. It's all about mindset. I'm a big fan of something called Every. Have any of you heard about Every? Well, anyways, they write a really long-form essays about AI and tech. And they coined this concept that they call compounding engineering. And I've grown really, really a big fan of the concept. And it's a bit of a mind-boggling thing. But once you sort of adopt that mindset into your work, it's super powerful. So a lot of my tips are actually supporting this mindset. And the concept is really this. Instead of just doing one-off tasks with your AI, you think of AI as a colleague, and you actively help the AI build knowledge base, help the AI learn your ways of working, and essentially, over time, see an improvement in how the AI acts together with you. And what they've achieved, obviously with some clever prompting, some setups of rules, and some frameworks that they've built, they've essentially come to the point where the AI becomes proactive in many contexts. So essentially, instead of you asking all the time for every single thing, they've actually have agents deliver something based on what you've given them feedback around over time. So this concept of compounding engineering is essentially that every interaction you teach the AI how you work, your preferences, your code base, your style, do this, don't do that. And over time, it behaves better and better. There are many levels to this, and the simplest one is obviously that you actively use rule files, no matter what coding agent you use. So for those of you who raise your hand and say you use ChatGPT, you ask a question and you copy-paste, you're going to miss out on that part, right? You might sort of have a project in ChatGPT and maybe sort of, to some extent, create rules and preferences there, yes, but it's sort of halfway there. Inside your code base, you can do a lot more. So that's sort of my tip number 0. Embrace this pair programming mindset. Look at how you can treat it as a junior intern or a junior developer, and not just a tool. And instead of just accepting the outcome, use this as a learning experience as well. Ask why, challenge, right? Actually, the simplest trick, which might be blatantly obvious, but a very simple and very powerful solution that I learned from the Anthropic guys, is that instead of just accepting that the output gets bloated or maybe too verbose, which AI tends to do, right? You just say simplify. You just ask it to simplify what it's done. You can make a habit out of asking it to simplify. You can even make a rule that at the end of a turn, it will always first simplify before it presents it to you. Another favorite of mine is super simple, ridiculous, actually, and that's make it better. Just ask it to make it better. You don't even have to review it first. You can be really lazy, and you can just say, after you get the first sort of response, you say simplify, and then you say make it better. So you haven't even reviewed it. You haven't even decided is it good or bad. You're just triggering it to try a bit harder. That's essentially what we do. Simple as that. Make it better. The great thing about make it better is that you can run it multiple times. Make it better, make it better, make it better. And you'll see big improvements if you haven't tried this before. To a point, of course. The best results comes from you actually reviewing it and actually giving concrete, specific feedback, providing enough context. So let's kick off with the 10 tips. Fasten your seatbelts. We've got 50 minutes to go through 130 pages. But starting with the maybe most important one, context is king. It's the fundamental piece of getting good versus bad results. LLMs, they have a precious resource, which is their attention span, essentially the context window. Now, we do have significantly larger context windows than we used to have just 6 months ago or a year ago, significantly bigger, but it's something we need to treat with care. It's not just bigger is better, because the problem if we give too much context, we end up confusing these models. Right? We may end up giving contradictory information. If we give too little context, LLMs, they make up stuff. And it's our fault when that happens. We haven't been specific enough. If we have asked for an output and we didn't say we would like it in bullet points, well, it's sometimes going to do bullet points. If we said we want 3 bullet points, we're going to get 3 bullet points. If we didn't specifically say 3, we might get 5, we might get 0. This applies to everything we do in coding as well, right? So context is something we need to treat very carefully. And I think context engineering, good context engineering is really about finding that sort of precious level of detail, the minimum amount of tokens that gives us the highest impact output. How do we capture context without bloating the context window, without confusing the AI? But obviously, there are some great ways to do this. You don't need to follow specific patterns and structure and prompting frameworks and stuff like that. That's not really the key. The ingredients is the key. Enough context. Here's a stupid, simple example. If I ask an LLM for a workout plan, it will give me a workout plan. But it's going to be AI slop, right? It's going to be generic. It's going to be something that fits a lot of people. But it's not specific. It's not relevant for me. It doesn't know enough context, right? A better, not like the best answer or the best example, but it illustrates the key difference here. I share my preferences. I share my starting point. I share my ambition, my goal, my time available to do workouts, etc. Then I get a much more specific result, a better result. But with all AI collaboration, and especially when we're coding, we also just need to have the mindset that it's not going to be perfect on the first try. So if you start thinking like that, you're going to get less disappointed, because the results are not great all the time. But it's very easy to improve, because we can give feedback. So rather than over-engineer and spend an hour figuring out the perfect prompt, don't do that. Just start somewhere, but give it enough context to rule out the most obvious mistakes. And then build from there. Iterate with the AI. Give it feedback. Say, I like this, I didn't like that. Avoid that, do this. But the more we can guide it, the better results we get. The good thing is that we can give and guide with context. not just through our prompt, but also by, for instance, sharing documentations, right? And of course, the biggest and most valuable part here is also to have an active management of rules, which we'll come back to. So you can, of course, in any tool, any CLI or any IDE, guide it, not just with documentation, but also say, instead of exploring the entire code base, I know that what I'm asking you for is going to be over here. So why don't you just say that and avoid the traversal and the search through the code base? Point it in the right direction. You save time and you save tokens. The rule files in Claude Code, we have Claude MD. In Cursor, we have Agents MD or Cursor MD or Claude MD. They support all of it. And in Codex or in Copilot, we use Agents MD. So they're all sort of the same, right? They're essentially the rule file. They're the sort of our special personal system prompt to the LLM in our context, in our code base. We can use this on a sort of overarching level across all of our repositories. We can use it on the repository level, and we can even use it in subdomains within our repository, in folders. It's a way for us to give clear instructions, and it's something that a lot of people miss out on, because you think, you go Google, give me a great Claude MD file, you copy that from that GitHub repository of someone who's created it, and then you save that into your project, and you're like, yeah, okay, got a little bit better now. The key difference is, or the thing you're missing out on is, your MD file, your agent file, your rule file is going to be your preferences, your style, right? So if you just copy something from online, or if you copy it'll give you some good results, probably, but it's going to miss out on your preferences, right? The other thing people do is they set it up once, and then just leave it like that. You're missing out on a big value here, on the compounding engineering concept, which is essentially to actively manage and update, right? Refine it over time. Use it as the knowledge base where your agent learns what you like and you don't like. So remember to utilize the rule files, which is what you will definitely miss out on if you're just using ChatGPT. Not saying it's bad to use ChatGPT. Don't get me wrong. I use it all the time as well. The other thing that I think a lot of people don't realize is that, as I said, context is precious. And then we just take for granted that these tools have become great at sort of automatically, for instance, compound once they start hitting the size of the window, right? Once the context is filled up, they will start auto-compounding. The problem with that is that we don't control when and what is included, right? So I would urge you all to have an active management of context. The way you work, you should keep an eye on your context window at all times, and there are easy ways to do that. You can, in Cursor, for instance, and in Visual Studio Code, you can actually go to the settings, and there's an option which is set to auto, which actually just means it will show you the context when you're almost filled the window. That's the default setting. Instead, you can set that to always, and then you will always see the context at any given time. So that's a simple way to keep an eye on it. If you're using Claude Code, you can use I use this thing called CC usage, which is just essentially providing my context number on the status line at all times. So I keep an active view on my context. Context, obviously, is not just your prompt. It's every turn. It's compounding as we go through multiple loops with the AI agent. So keep an eye on it. And then my way of doing this is, as I finish a task, I will always clear and start a new chat. So I will always reset. And then you say, but what if I had some valuable information in there? Well, then we use Markdown files. And I know, you all hate Markdown files. You hate those filled folders with AI slop in. But just forget about that. Who cares? You don't need to read those Markdown files. Just think of them as AI docs. It's not docs for you. You don't need to think about it. If you're embarrassed with your colleagues, just put it in git ignore. And don't commit that folder. It's fine. No one needs to know. But it's a great way to capture context. You just ask the AI to summarize so that we can continue developing later. Just something like that. Recap everything we've done, our current next steps in a Markdown file. Just something like that. Then, once it's done, /clear. new conversation. And now, you just inject that context as your starting point. Let's continue developing where we left off, at, and that a markdown file. And now you have a clean, compressed context starting point, which captures everything that you were doing without all the noise. So actively managing your context is key to better results. Don't let that auto-compact happen, because then you're out of control. I mentioned, and I'll come back to this later on as well, but I mentioned in Claude Code specifically, we have something called sub-agents. And I just want to mention it in this context, that sub-agents, they actually have their own context window. So that means that we can, if we're clever, actually achieve endless context, which means that we can have in our main thread with our agent essentially ask it to use sub-agents to do tasks. We can actually do things in parallel. We can say something like, for each of these 10 files, use a sub-agent and do the following. And it will essentially just give the task to the sub-agent, and it will not pollute the main context window, and then the results will come back, only the results. So there are some really clever ways to exploiting the context limitations that we have. Rules. So in Claude Code, we have a /init command. And even if you're not using Claude Code, I would urge you to create something similar in whatever your environment is, or use Claude Code to do /init and then just copy the output into your favorite coding assistant. /init in Claude Code essentially explores the code base and generates your initial Claude MD file for that project. Not just a generic rule file that you copy from GitHub, but actually tailored to your existing code base. Use it as a starting point, but make it an active file that you update and keep managing. In addition to the rule file, we can also, of course, reference documentation. A lot of people use context 7 as an MCP to essentially give access to docs. That's OK. It works. But a lot of the times, you don't need all the docs, right? Again, remember, everything we're sort of throwing in at the coding assistant is filling up the context window. So sometimes you should be very selective and just essentially pick the right docs for the job. The great thing is that most frameworks have AI-friendly docs. There's often a copy as markdown button in the docs that you find online. Or there's an llms.txt file that you can essentially just reference. And some of them, like here in Superbase, they even have like rule files specifically for coding agents. So let's say one of the things that or agents often struggle with is, how do I write migrations, for instance? So if you're using Superbase, just copy the migration rules, drop them into your folder, and when you and only when you are working on a task like that, you essentially just add that and say, make sure you follow the rules here. Be specific and be explicit about what rules to follow. Yeah, and for whatever you need, Markdown or LLMs, often it's better to just drop it into your folder and reference it. You can put it in your AI docs folder and put it in git ignore if you don't want to pollute the repository. But it just helps increase relevant context for the tasks you're working on. And again, I can't repeat this enough. You have to have an active management of your rules. It's not something that you set up once and you just leave it there to die. So whenever you catch yourself getting frustrated with AI, that's your signal. Now I need to tell the AI to avoid this in the future. And in Claude Code, you can use the hash sign to essentially memorize. Or with any of these, you can just say, please update your rule files with this learning. Or please add this to your memory so we avoid this in the future, right? Something along those lines. Everything I'm saying is like something along those lines, because there's not like it's exactly these words. I'm just saying it so that you can sort of make it into your own. But something along those lines. And it's really powerful to do that. I'm sure a lot of you have had your gripes with AI where you're like, I've told you now 5 times, and you're still doing the same thing, and we're doing this in loops, and it's really frustrating, right? But once you finally get out of that loop and you find the solution, there's a bunch of missteps in that chat, yes, but always when you have that feeling that finally, then the worst thing you do is just move on. the best thing you do is remember then to say, now let's recap all these rabbit holes we went through so that I never again have to experience this painful experience with working with you in a markdown file or in my rule file. And it will recap it. Sometimes he will even use caps in the rule file and say, never do this, right? But that's how we train it and how we improve, right? How we avoid that in the future. If you do that, I will bet that you're going to get better and better experiences working with AI. But you're not going to achieve that by just trying it out once and say, the results were AI slop. I'm going to go back to writing my beautiful code myself because I'm so great at writing code. Okay? Choose to do that, but you're missing out. That's my personal opinion. Another thing you can do is also actually, based on how you write code, you can also ask it to evaluate the code and to extract patterns and anti-patterns from your code, from your team, right? This works in collaborative repositories as well, right? So essentially just ask it to extract the 10 sort of key commandments from our way of writing code. And it might not be perfect, but it's a really good starting point, and then you can be the human in the loop and review it, and you don't have to start from scratch. You get the starting point from the AI, and then you can say, well, actually, that's not correct. I'm going to change that. But you get significantly better results. Then you drop that into your rule file and say, always follow these practices or these principles when you write tests, for instance. LLMs loves examples. Sometimes they exaggerate and they create too many examples, but they love examples. So instead of just saying in words, do this, don't do that, show it. In your rule file, you can include examples. Here's the pattern that you should use, right? With code. And I think a lot of people don't do that. They just write in natural language, but use examples significantly increases the results. They also love structure, LLMs. So you can also feed it. Sorry, we don't have time for 1 point at a time. We are running out of time. So you can also essentially use structure like JSON or XML. They're better at following rules when they're well structured than just a wall of text. So be a little bit conscious about this, but I would always urge people to start with /init, because then you get a starting point written by Claude the way Claude likes to read rule files, right? So essentially, you get a very good starting point. Moving on. This one, I think, is underrated. Once you get into the habit of it, there are many, like, you should use this framework, you should this approach, you should use spec, or you should, I don't care. I mean, the point is to actually enrich the context to avoid the LLM ending up making decisions for you, right? That's the point of making a plan. Because if we don't, the LLM will just say, well, it didn't say what map library to use, so I'm just going to pick Leaflet today. Tomorrow I'm going to use Google Maps, whatever, right? So we need to be specific. Making a plan helps us, essentially forces us to be specific. But instead of us writing that full spec ourselves, we just ask the AI to help us, right? So Cursor has plan mode, which you can actively select. All the CLIs have some sort of shape and form of plan mode. And if your tool does not, you simply ask it to make a plan. And ask me clarifying questions before you proceed. Along those lines. In Claude Code, we can enter plan mode by hitting Shift-Tab, Shift-Tab. Then we're in plan mode. It will not change any code. It will not do anything. It will only make a plan. But it will always ask you questions based on whatever prompt you sent in, right? I'm not saying you need to make a plan if you're just making a small fix or something like that. That's fine. But when you're building a feature or when you're trying to resolve a bug that is more, somewhat complex, yeah, make a plan. Ask it to make a plan. And as a bonus, ask it to ultra-think. You get rainbow colors in the terminal, which is always cool, and it actually just allocates more thinking budget to the model. You no longer have to actually type in ultra-think, but I just do it out of a habit. If you just hit tab, it will turn on thinking mode in Claude Code. But ultra-think is there, I think, for for those that started early and used it. So yeah, combine plan mode with thinking, and you get really, really good results. Try it out. But you have to give it enough context to make appropriate plan. You can also then say, what a lot of people do is they just sort of make a plan, and then they say, yeah, sounds good, let's go. I would urge you to make a habit out of, before you say let's go, obviously review the plan, but let's say you're happy with the plan, then just ask it to put the plan in a markdown file so that we can keep it for later. And you might never need to go back to it, but if something happens, if you sort of go down the wrong rabbit hole, and if you sort of have to stop coding because you have to go back to your family and stuff, it's nice to have that original plan. And that original plan gets sort of polluted behind the scenes. Yes, it's there in the to-do list behind the scenes in Claude Code and in Cursor, but just keep it in a markdown file. And then you can ask the agent to tick it off as you progress, right? Once you're done with part 1 of that plan, you say, great, let's update the status in our plan before we move on to the next step, right? As a bonus, you say, add any key learnings to our rule file. Actively managing your context, building the knowledge base between you and the AI. You can use any framework as well. I hate writing long specs, but I just say, here's the gist of it, here's my keywords, now you write it into a nice format that I can shamelessly put on my GitHub issues, and it looks really professional. It captures the essence, but it just elaborates for you. The thing is, it's not just because it looks good, but it's actually then giving better context when you inject it into the agent next time you want it to solve that issue for you. Yeah, just a last little comment is that when you're in plan mode, you can also ask it to generate visuals. You know, like ASCII art is actually really helpful. Just ask it to visualize this and say what is it that we're trying to build, for instance. So that's just a little trick that you can use. If you want to, you can of course also add some MCPs and actually ask it to use, for instance, Nana Banana to create a visual mock-up for you. It can do that as well. And then that becomes part of your context, right? So just be creative. I think as we see these capabilities evolve more and more, and it's sort of getting a bit scary how much they can actually do, we need to remind ourselves that we're going to end up with AI slop if we get lazy and we just accept what comes out of it, right? So what do we have as developers to contribute within this collaboration with AI agents? It's our taste, our ability to judge, to evaluate, to give feedback, to essentially make decisions, right? The architectural decisions, but also sort of the design choices, the user experience. It will make up solutions and propose solutions. Sometimes that's what we want. Sometimes we can extend our sort of our own creativity with the help of AI, but at the end of the day, we need to be the human in the loop, and we need to make those choices. And that's an active choice that we have, and we can train our AI to learn from those preferences by essentially saying, I don't like this. Please avoid doing this. Never use this approach. Simple as that. Just talk to the AI. Don't just make it like a command and accept approach, but actually have a conversation, as if you were having a conversation with your coworker when you're doing code review, right? So I think even though you might not be a big fan of writing big specs, etc., just leverage the AI's capability of doing so, right? Even if no one else is going to read it, it's a way for you to better structure context, to expand on your prompt. And you can always do that, right? You write your prompt and you say, help me improve this prompt. Just ask it, how could I improve this prompt so that I get even better results with my AI coding assistant? Instead of just giving you the answer, it will also explain you were missing this piece. You should probably also explain this. You should be more specific about the framework choices. And you're learning along the way. You just need to have that mindset. This one is pretty obvious. I'm not going to spend much time on this one, but yeah, break it down into smaller pieces. A tip is to use, for instance, if you're using GitHub, use GitHub issues. A lot of the time when I'm working with AI tends to sort of give suggestions as well in the middle of focus work, right? We're working on this thing. Why are you now suggesting 3 other things? But sometimes those 3 other things are maybe interesting, and you might want to explore them later. Now, then the trick is to say, right now, let's keep doing what we're doing, but please add these 3 ideas to GitHub issues so that I can look at them later. And if your AI assistant has access to the GitHub CLI or the GitHub MCP, it will do that, right? It will send it off to GitHub for you. When you're making a plan and you got like 5 steps in that plan, or you got some bugs that you've realized, well, just ask the AI agent to write up a summary with enough context and add it to GitHub issues. You can go in and change it later, that's fine. But it's a very powerful way to capture context that you can use later on. And if you're not using GitHub issues, you can do the same thing in linear, or if you don't even have a bug tracker or a roadmap management tool, you just use Markdown files. That also works. Or Notion. You can just use the Notion MCP and essentially send it off to Notion. So make use of that, capture ideas and actively manage it, and you can just tell it, please create an issue for me about this, and elaborate and make it comprehensive. And it'll expand on your simple sentences. So that's fairly straightforward. I would urge you to use the GitHub CLI for that, because that also works with the background agents or autonomous agents, which don't always support MCPs. So yeah, break it down. I think it's sort of an obvious one, but it makes sense. We have some choices when it comes to models, and I think I would always use the best models for the jobs. But it's easy also to get into a habit once you start with something. It's like, I can't be bothered to switch to another model now. I'm getting good results here. It's okay. But having an active choice of model, like for instance, for a simple task, you might not need Opus or the most powerful thinking models, right? So you could actually get away with choosing something like Haiku to do the job at a fraction of the cost, in essence. But there's also something interesting is that these models, obviously, they are a bit slow. Most of them are, right? Because they're essentially taking their time going through their thinking process and essentially using tools and stuff. But if you haven't tried it, I would urge you just to test it out for fun. In Cursor, they launched their new model 3 or 4 weeks ago, and it's called Composer. And what's really interesting, it's not like the same level as Opus 4.5 or Gemini 3 Pro, but it's really good, but it's super fast. And if you try it, you'll be like, wow, it's actually doing stuff this quickly when I'm used to Claude Code working really, really slowly. So for some simpler medium tasks, you could definitely try. And the bonus is, if you're like really all in on this, you will hit that limit, right? The usage limit after X number of hours, even if you're on the max plan and you're paying $200 per month. Well, the thing is, you can then work on one, and then you just switch over to one or the other while you're waiting for that usage limit to reset. So you don't have to do a 4-hour break, although sometimes that could be maybe smart. So yeah, just be active in your choice of models. But these models today, they're sort of, all of them are great. Yeah, and all of these coding tools, they obviously offer us a bunch of different tools in the agent harness. So for instance, in Claude Code, we have slash commands, which you also have in all the other CLI tools, right? You also have them in Cursor, in Copilot. So most of them have sort of the same functionalities, but Claude Code has a few more things that the others haven't yet implemented. So just be aware, some of these tips might not work in your agent if you're not using Claude Code. But hopefully and most likely they will be available soon. So slash commands is something that, once you find yourself doing something repeatedly, that should be a sign that you should turn it into a slash command. So something that is repeatable, something that you frequently do, you can just package it up as a slash command. And slash commands can be really powerful because they're not just a simple prompt. You can essentially also have variables in slash commands. So you can, for instance, say something like, review PR 123 hi Alex, and that slash command expects, a PR identifier, a priority maybe, and an assignee or something like that, right? So you can essentially make fairly sophisticated slash commands. You can also ask your AI to use slash commands in the rule file. So you don't have to actually, we say slash commands are human operated, but they are not necessarily only that. Yes, we can do slash and whatever, but you can also in your rule file say, every time you've finished a task, before you present it back to the user, always run write unit test. And then that instruction is not polluting the agent MD file or the Claude MD file. It's written in a separate file, but it gets loaded into context when needed, right? So that's just a way to sort of repeat and cleverly manage context. Something a lot of people don't know is that you can actually also, in a slash command, you can also include bash commands and execute them as part of the command. So if you sort of add this exclamation mark to the instructions in the slash command, you can do some really clever stuff. So I urge you, if you're interested in that, you should check out the docs and see some examples of how to do that. But that's sort of next level use of slash commands. But get started, it's really powerful. Sub-agents, as I mentioned, they have their own context window, which is one key thing. But also, this is where you can essentially say that you want to parallelize, or you essentially want to create a very specific role definition of a particular task. So for instance, we can, just skip to the next one. We can create sub-agents for code review, for documentation, for QA. We can do sort of integration testing. There's a bunch of these type of tasks that we can define up. We can ask the AI to help us define it up as well if we don't know how to write that description. So we essentially get a starting point from our coding assistant, and then we can make use of those. And you can also chain sub-agents. So it's actually pretty cool where you can say, first use this sub-agent. Once that finishes, then you can use that sub-agent. And as I said, you can also run them in parallel, essentially. So this is not just for coding, but you can essentially say, I've got 100 PDFs in my folder here. I want you to create a sub-agent. For each of those files, I want you to do the following. And then all of a sudden, you're parallel processing 100 PDF files to do whatever you want to do with those PDF files. So definitely worth checking out. Obviously, something that I would urge you to do if you're in a team and you sort of share those sub-agents. That's obviously a powerful way to collaborate as well, so everyone sort of follows the same approach. Another thing we have is something called hooks. And in Claude Code, we have Claude Code hooks, which are essentially originally built to provide us means of guardrailing around and outside of the LLM inference. So essentially, before and after any event happens in the chain. That's very handy. I'll come back to the soft hooks, but that's very handy. There are some events that we can trigger hooks on in Claude Code. For instance, every time Claude Code needs to interact with a user. I know the Claude Code team, they use this one to essentially ping a Slack message when Claude Code is asking for input. Because at least I often wander off and grab my coffee and end up chatting and stuff like that while the agent is working. And it could have been working more efficiently if I just knew that it was waiting for my input, and I can then continue with whatever I want. So that's a silly but maybe useful one. But you can also add hooks like once before it does a tool call, you can add checks so that it's not allowed to do this and that, and it can't change this and that. After a tool call has been used, we can also add in a hook. So there are many, many ways we can use hooks to control and direct our AI coding assistants. And we can also add in things like once it finishes, we want to make sure that it always writes tests. Or, for instance, if tests fail, I don't want you to tell me you're done, because then you're not done. So if a test fails, continue. You can add that to a hook. You don't need to give that input as users, which we often have to do, right? We have to say, well, please continue. So now we can just add that as a hook, and it automatically continues. So those are really powerful, but it's also beyond guardrails, right? So we can actually also use this in the concept of our compounding engineering. So in rules, and this works across not just Claude, because this is more the soft hook approach, right? Where we can actually say, every time in your rule file, every time you've finished a feature, always write this and that. Or we can say something like, every time the user tells you not to do this, capture that in the rule file. You can actually ask it to self-improve the rule file without you actually telling it to update the rule file. So in the rules, we tell the agent to update its own rules. That opens up a lot of interesting opportunities. You can ask the AI to give you suggestions on how you could use this and what type of interesting hooks you can create, and you'll get some inspiration there as well. Last one I want to mention, I'm not going to dive into this one, but just recently, a couple of months ago, Anthropic launched something they call Skills. And a lot of people were like, yeah, but isn't that just like a markdown file with some descriptions? And yes, it's stupid simple, but the key thing is that it's a way where we can package up tasks with code that is reusable. That's a key thing. We can actually have small scripts as part of the skill. And then the key difference is with our slash commands and our sub-agents, generally it's us telling the AI to make use of them, either through our rules or us actively using a slash command. Skills, on the other hand, is something that we inject into the mindset of Claude or our agent, and essentially it will evaluate, should I use this skill to achieve this task autonomously? So it's a way for us to essentially guide the AI beyond just the rule file. So it opens up some quite interesting aspects, not just for coding, but that's something that would require another hour to explain all of it. The beauty of it is that they use something called progressive disclosure, which means that it's not really polluting much context at all until it's needed. So essentially, it uses YAML front matter, and we only load the first few lines of the front matter. That's it. And then once it decides that now I might want to use this tool, this skill, then it can load progressively more and more of the skill. So it's a very elegant yet simple way of managing context. All right, time flies, so let's jump on to the next one. Maybe the first part here is obvious, but yes, we need to use source control, and especially when we work with AI coding assistants, they will make mistakes. They will mess up your code. So always make sure you have a way to roll back. Fortunately, now they all have built-in sort of checkpoints. They didn't all have that. So actually, we had to use Git when we were early adopters of Claude Code. Didn't have built-in checkpoints. But now you can essentially use checkpoints or essentially Git to roll back. The cool thing is that we can also fork conversations, and we can also run things in parallel. With most of these tools, we can even run multiple models on the same task. That costs a little bit more money, but it also can be useful when you want to explore something, right? You essentially want to say, I'm not really sure what I'm looking for here, but let's try to implement this thing here, and you try to run it in parallel with 3 different models, or maybe 3 sort of slightly different approaches. You can do that, and then you essentially will have a fork for each of them, and you can decide which one to proceed with or not. But actively using rollback is important. And I would, in Claude Code, we call it rewind. But in Cursor, for instance, you essentially can click on the restore checkpoint button in your chat to go back to whatever point in the conversation where you knew things were working. But again, make sure you capture learnings when you hit those rabbit holes, when you've gone through loops, when you've gone through the wrong solutions. Not just the right solutions, but the wrong solutions as well, right? Just tell it to capture the learnings. I don't want to experience this frustration ever again. Please update your rule file. Just say something like that, and it will recap it. What happens if you do that a lot, and if you get into that habit, the side effect of it is that your rule file can grow and become bloated. in Claude Code, it will tell you your rule file is now more than this size. Maybe you need to review it, which is great. So don't just leave it there, but once in a while do a review. But of course, you can just ask Claude to please review the Claude MD file, remove any duplications or superfluous information, provide me with a revised version, and make a copy of the old version for safekeeping. Or you have it in Git, then you can just roll back. But that's a way to compress information while maintaining the key points of the rule file. So just have a little active management of the rule file. This is something that I sort of along those lines say, now that we finally managed to fix this, I want you to capture the learnings from this conversation in a markdown file so that we can avoid these mistakes in the future. And sometimes I tell it to update the rule file. Number 8, MCP. MCP, how many of you use MCPs? How many of you know what MCPs are? Okay, well, I'm not going to give you an introduction to MCPs, but yeah, a lot of people call it the USB-C for AI. Key concept here is that we have a protocol that all the major players have sort of joined forces and support and say, okay, this is what we back and this is what we want to support. And it allows us to give a plug-and-play solution for any and all models, harnesses, host applications that has an LLM to communicate with tools, mainly for context enrichment, but more and more also for equipping them with arms and legs to perform actions. So it's not just about enriching context, it's also something we can use to perform actions. Like, for instance, create this pull request, or update this file over here. A lot of these coding agents, they have access to, if they're a CLI-based agent, or if they operate in a sandbox environment, they may or may not have access to bash tools, which is not necessarily MCP, but it's another type of tool. So I'm sort of extending the definition there a little bit. It's not just MCP. But this opens up a lot of interesting capabilities for our LLMs. For instance, we can give them access to GitHub, as I mentioned. Context 7 is another one, which is essentially a search engine for documentation. So we can essentially inject relevant documentation without us having to go to all of those pages, downloading the docs, etc. So that's a very nice MCP. We have a bunch of sort of browser front-end related MCPs. What they do is essentially giving our LLM the ability to interact with the browser. So instead of it saying, I finished, then you have to go and run that web app and test it in the browser. Now the LLM can actually do it for you, which is nice. But it's also something that consumes tokens, and it's not always necessary for us to do that. But it's something that obviously can help us by testing and also writing tests as well. Chrome DevTools, they have their own MCP server, which I would highly recommend. It allows you to not only interact with the browser, but also to interact with Chrome DevTools and essentially look at the network log and the console and all of those things that we normally do as developers, if we're front-end developers. In Cursor, we have a built-in browser now, which is nice. It's essentially doing what we previously had to do with an MCP. We can do it now inside of Cursor. And if you've tested the new VS Code, the VS Code clone that Google launched called Anti-Gravity, they also have a even more sophisticated built-in browser, obviously, because they own and manage Chrome. They built in Chrome and allows the coding agent to interact with Chrome. And it even does screen recordings and screen captures. So once it's done, it says, I'm done, and here's the evidence to prove that I'm done. So that's cool, but it burns your memory on your computer, so I would sort of wait a few weeks before you actually start using anti-gravity. But there's a bunch of MCPs. Only thing I want to say that these MCPs, they bloat your context window. So let's say you add in GitHub, the MCP. The MCP has 40 tools. So before you even send your first prompt, you've already filled the context window with the complete tool definition of 40 tools. And then you add a few more, and then all of a sudden you've spent quite a lot of context. Fortunately, smart people come up with very simple yet elegant solutions. So last week we got an approach from Anthropic where they essentially say, what if we just give you a tool search tool, and it just uses 500 tokens, and that's what we load up front. And then if and when the agent needs to use GitHub, it will search for GitHub and then load only the tools that it needs and the definition it needs. So it's a very simple yet super elegant way to deal with the context problem. But just be aware, MCPs, they eat up context. And there are some security concerns. That's the S in MCP, security. Come on. Claude Code, you can simply add the MCPs in Claude Code as well. In Cursor and Visual Studio Code, etc., you just do it from the settings menu. So it's fairly straightforward. And you can both let the LLM use the MCPs, but you can also trigger parts of MCPs. So you can essentially use slash commands in Claude Code against the MCP servers. So definitely explore it, and I'm getting to the end of my time here, so I need to wrap up. Last part is essentially releasing the agents. So this is sort of next level, letting loose the agents. Most of these now support background agents, essentially agents being spun up in a sandbox environment. And you can pull all of my tricks together and say, let's work on this issue in GitHub issues, and you at Claude, or you at Cursor, even in GitHub, and it will actually spin up an agent for you. It will work on it. It will create a pull request for you that you can review. I would urge you to try it out, because it's really cool to see how they're now able to solve a lot of things on a sort of one-shot prompt, as long as you give enough context. So if you have good context in your issue in GitHub, they'll be able to solve amazing things. And I'm sorry I'm over time, so I need to skip through this. Last point is be the human in the loop. AI can do a lot of great things, but let's not become complacent. You say, are you sure? And Claude will answer, you're absolutely right, I made a mistake. I'm going to make that mug and start selling that mug, actually. But just be the human in the loop. We should not take it for granted that everything is correct. Do as we've always done, do code reviews, make sure that we own the code and understand the code, but we can also ask the AI to help us explain, what have you done? Take me through this step by step. Explain it to me as if I'm a 5-year-old, and it will actually take you through what it's done. And just add that keyword, simplify, so that you can reduce the bloat. So yeah, that's it. I'll let that run. If there are any questions, feel free. If not, thank you very much.